So in the comparison of means, we have one more upcoming. I got a message from somebody not able to join.
So me, I have sent you the message. Now I am able to join the class.
Okay, okay, fine, fine. So yesterday we were talking about the comparison of means. We have talked about the different kind of t-test, that is the one sample t-test, independent t-test, and pair t-test. Now moving forward, let's look upon what happens, because pair t-test and independent t-test can only handle the case when you have a independent variable divided into two categories. What if your independent variable is divided into three or more categories? At that point of time, we have to go for ANOVA. However, this ANOVA, if you talk of, this is basically a GLM model, generalized linear model, and there are five generalized linear models in which one-way ANOVA and two-way ANOVA falls into the category of GLM1, and COA falls into the category of GLM2. For your convenience, let me write over here. So these ANOVAs are analysis of variances or generalized linear model, and we have five kind of generalized linear models. So GLM1 is one-way ANOVA, and of course two-way ANOVA. However, two-way ANOVA case means if you have more than one independent variable, then two-way ANOVA case will be there. And we have GLM2, which is ANCOA. Then we have GLM3, which is this factorial ANOVA. And we have GLM4, repeated measures ANOVA. And we have GLM5, which is mixed design or mixed ANOVA. So ANOVA is not only about one-way ANOVA. There are five GLM models: one-way ANOVA, two-way ANOVA, GLM1, GLM2, ANCOA, analysis of covariance, GLM3, factorial ANOVA, GLM4, repeated measures ANOVA, GLM5, mixed design ANOVA.
So what is the full form of GLM? General Linear Model.
Generalized linear model. It's generalized linear model. So agenda for today's session will be one-way ANOVA. I will restrict only to one-way ANOVA. The reason being, the other GLM models, ANCOA, factorial ANOVA, repeated measures ANOVA, or mixed design ANOVA, you will understand only when you understand the regression. So as of now, I will restrict myself to one-way ANOVA only. Now this one-way ANOVA compares the means of three or more independent groups in order to determine whether there is statistical evidence that the associated population means are significantly different. So it's just, you can say, the extension of the two sample test. So one-way ANOVA, where in two sample test, you were testing the uh, case where you had only two groups in your independent variable, Here, if you have three or more groups or more than two groups, then you will go for one way ANOVA. And this one way ANOVA is a parametric test. Again, that follows the rules of normality, the assumptions of normality, and data taken on a metric scale. The data should be metric, taken on a continuous scale. All these assumptions are met, then it becomes a parametric test. So this test is also known as one factor ANOVA, one way analysis of variance, or between subjects ANOVA. The variables used in this test are known as, one is dependent variable and another one is independent variable, also known as the grouping variable or factor. And in the factor you have cases which are more than two and which are mutually exclusive of each other. Now, the common uses of this test is that it is often used to analyze data from the following type of studies, like field studies, when you have many groups. When you have many experimental groups, then experimental studies it is applied, and quasi experiments means when you are not actually in the laboratory setting, you are not doing any experiment, but you are doing quasi experiments. Then also, and having more than two experimental groups, then this one way ANOVA is used. So normally it is used to test the following: the statistical difference among the means of uh, two or more groups. Basically, if we write it three, it will be better. Three or more groups. Then statistical difference among the means of three or more interventions. You can see that it's just the extension of two sample test. There we have the there we measure the statistical difference among the means of two groups. Here we measure the statistical difference among the three or more groups. Here, there we measure the statistical difference among the means of three or more interventions in clinical or experimental study. Here we measure the statistical difference among means of three or more interventions. There it were two interventions only. Then statistical difference among the means of three or more change scores. So for this purpose, this ANOVA is used. Then data requirements for one-way ANOVA is, there should be a dependent variable that is continuous, means taken on interval or ratio scale. The basic assumptions of all the parametric test. Independent variable should be categorical in nature, means your grouping variable or independent variable should be categorical in nature. You should have cases that have values on both the dependent and independent variables. Whatever the values, whatever the cases you have collected, they should have their representation in both the dependent and independent variables. There should be independence of observations. The observations should be mutually exclusive of each other. They should not influence, means no group should influence the other group. Otherwise, the p value will be wrong. Data should be drawn from a random sample. That is, the sample that you have taken should be taken randomly. Data should be approximately normally distributed. There should be homogeneity of variances, means variances approximately across equal groups. Then the hypothesis that is framed in this case is, again you will frame the null and alternative hypothesis, and the hypothesis there you had mu1 is equal to mu2. Here you will be having mu1 is equal to mu2 is equal to till mu k, means till the end. You may have as many number of groups. So you can say that there exists no significant difference among different groups. So all population means are equal. Then you have the alternate hypothesis, which says that at least one of the means is different. Okay, or you can say at least one mu I is different, where mu I is the population mean of the ith group. Okay, I could be one, two, three, four, or let's say third group, the mean value, or the fourth group, its mean value is different. Then you will say that mu four is the mu, at least mu four is different from the other groups. So null hypothesis state that there is no difference among the among the groups, means all the population means of all the groups are equal. Alternate says that at least one of the group differs from the other groups. Clear? Am I clear on this?
Yes, sir.
Okay. It's just the extension of, you can say, the PRT test. So the data setup that is required in the ANOVA, that your data should include at least two variables. However, there should be more than two represented in columns that will be used in the analysis. The independent variable should be categorical, nominal, or ordinal, and include at least two groups, and the dependent variable should be continuous. Each row of the dataset should represent a unique subject or experimental unit. Now, this is the problem statement. Let's open the dataset first. Same dataset that I sent you yesterday. We'll be using the same dataset. First, let's open the dataset. So go to File, Import Data. Wherever you have saved your data, just go to that. In my case, it's here. So now we have the data. I hope you all are with me.
Yes,
Clear?
sir.
Okay. So in our given data set, there is a variable called sprint. Okay. It is the respondent time in seconds to sprint a given distance. You can see here sprint. It is the respondent times in seconds to sprint a given distance. And then we have a group called known as smokers. Means it is a group of smokers where it is divided into three categories, where zero is non-smoker, one is past smoker, and two is current smoker. So this grouping variable smoking is an indicator about whether or not this respondent smokes. Again, this respondent is divided into three categories: non-smoker, past smoker, and current smoker, indicated by 0, 1, and 2 respectively. Now here we will use ANOVA to test if there is a statistically significant difference in sprint time with respect to the smoking status. So this sprint time, actually the sprint means the time taken to run a short distance. So we have to see that whether smoking has some relationship with the uh, time taken by the people to run a short distance. So here the sprint time will serve as the dependent variable, and smoking status will act as the independent variable divided into three categories. So before the test, as in the pair t-test and the independent t-test, we have looked at the descriptives. Similarly, here also we will look at the descriptives. So we'll go to analyze and then descriptive statistics and descriptives. And here we will see only the time, sprint time. Okay. Now here you can see that the sprint time exhibits a range of 4.5 to 9.6 seconds with a mean of 6.58, or you can say 6.6 seconds, and number of valid cases in this case is 374, right? Further,
So please elaborate standard deviation also. That is 1.23. How? What does it mean? Um.
are you aware of the normal distribution curve?
Yes, sir.
So if you look at the standard, if you look at the normal distribution curve, okay, I don't have the here the normal distribution curve, else I would have just elaborated you. So it is actually this number standard deviation tells that how much the members of a group differ from the mean value for the group. So you have a mean value of the group, right?
Yes, sir.
So you can see here that this is the mean. Okay, the standard deviation means that the members, means all these people, they have a difference, means uh, they have a difference of 1.2 from the mean, means they can deviate to a point of 1.23 from the mean value. So if there will be higher standard deviation, it means the values are far away from the mean. And if you have a low standard deviation, this means the value are close to your mean value. Any confusion over here?
सर ये तो समझ में आया बट एग्जैक्टली नहीं समझ में आया व्हाट्स द मीन ऑफ 1.23
See, 1.23 means, see, first see your mean value, which is 6.58.
58
Okay. So from this, within this mean, you can say that the respondent can deviate to a point of 1.23. यानी जो total value होगी वो 6.58 plus minus 1.23 आएगी आपकी.
ओके सर नाउ आई एम गेटिंग योर पॉइंट
अभी क्लियर हुआ?
यस सर
जो
यस सर
जो आपका टोटल मीन वैल्यू, एक्चुअल मीन 6.58 है, लेकिन जब आप एक्चुअल वैल्यू लेंगे तो 6.58 प्लस
प्लस
माइनस
माइनस
1.
6.58 से 1.23 ज्यादा भी हो सकती है कम भी हो
कम
सकती
भी
है
हो सकती है. अगर आप नॉर्मल डिस्ट्रीब्यूशन में देखें, -2 सिग्मा से +2 सिग्मा के बीच
प्लस
की
2
जो
हाँ जी
रेंज है, उस रेंज में ये निगेटिवली स्क्यूड 1.23 हो सकता है या पॉजिटिवली स्क्यूड 1.23 हो सकता है,
यस सर नाउ आई एम अंडरस्टैंड
राइट? So standard deviation gives you a insight that how much your this observations, they tend to deviate from the mean value. क्योंकि कोई भी चीज कभी भी accurate नहीं होती है, तो कुछ deviation उसमें होता ही होता है. This deviation is standard deviation. बहुत ज्यादा standard deviation आ जाता है. Suppose if you have a mean of 6.58 and standard deviation of 10 or 8 point something, this means there is something wrong with your data set. Clear, ma'am?
यस सर यस सर
Okay. Now, the second step, as we have done, so go to analyze, compare means and means. Again, you take the dependent list as sprint and independent list as smoking. Click on OK. This will give you the overall statistic. And here you can see that there is some difference between the mean values of non-smoker, past smoker, and current smoker. And Now further we have to check that whether this difference in the mean stands statistically significant or not. Here it is telling that okay, there exists a difference between the non-smoker group, past smoker group, and current smoker group, but whether this is statistically significant or not. So for that, we will go for testing the ANOVA, one-way ANOVA, analyze, compare means and one-way ANOVA. Take your independent variable, take your factor, that is your independent variable or grouping variable, which
Smoking.
is smoking, and also since it has shown already in the mean value, you have already seen that there exists a difference between the three groups. The means of the three groups were different. Now we want to know. See, ANOVA, one-way ANOVA will only tell you that whether this difference is statistically significant or not. But further, we also want to know that statistically which group differs from the which group. Overall, it will tell you that okay, all the three groups will have a different effect on on the sprint. Means non-smokers will have different sprint time, past smokers will have different sprint time, and then your current smokers will have different sprint time. But which one is significant with other? Because if it would have been only two groups, then only it was a comparison between the two groups. You can easily tell that okay, group one differs from group two significantly. Now you want to know also that whether group 1 differs from the 2 and 3 or not, whether 2 differs from the 1 and 3 or not, or whether 3 differs from the 1 and 2 or not. Because ANOVA will only tell you that groups differ. Which group differs from the which group, that can be only known by the post hoc analysis, which is the further exploration of the one-way ANOVA. So go to post hoc. And for this kind of data, the dependent variable and the grouping variable, you have the best method for doing the post hoc is Tukey HST. Click on Tukey HST. Bonferroni and others are there, but they are used in Factorial, ANOVA, and others. So here you will choose only Tukey HST. Continue. Okay. Now let's look at the data set. Now what does this one-way ANOVA tells? Let's look at it. What inference we can draw from here? What can we conclude?
So p value is, I mean, it's a significant.
So null hypothesis is rejected,
Yes,
Yes,
sir.
and if null hypothesis is rejected, it will tell us that at least one of the groups differs.
Yes, sir.
So we will write here the results that the mean sprint time is significantly different for at least one of the smoking groups. First, we will write simply that F degree of freedom 2 350 is equal to 9.21. At this, the value of P is less than 0.05. So, null hypothesis rejected, which means that the mean sprint time is significantly different for at least one of the smoking groups. Now, it will only tell you that only at least one of this group differs. Now, which of the group differs from the which one? For that, you have to go for the post hoc analysis. Now, the post hoc analysis says, now let's compare 0 with 1 and 2. What is the significance value? 0.140. Isn't it? Do you have this table with you or not?
Yes, sir.
So if you compare, do a comparison of the group 0, 0 means non-smokers, with the past smokers and the current smokers, you find there doesn't exist any significant difference between the non-smokers when compared to the other groups, past smokers and current smokers. No difference, no statistical difference. However, when you compare this group 1, that is past smokers, with the non-smokers, again there won't be any statistical significant difference.
सर जो फर्स्ट में 0 फैमिली का 2 के साथ है वो तो सिग्निफिकेंट है सर।
मैम उसको अगर हम तीसरे वाले में देखें तो हमें बेटर रहेगा ना, हम यहीं पर क्यों लिख दें? आप देखिए ना, जब तीसरे में देखेंगे कि 2 को जब कंपेयर करेंगे तो कहेंगे हाँ है। आर यू गेटिंग माय पॉइंट? मैम यहां पर भी हम कह सकते हैं कि 0 का 2 से सिग्निफिकेंट डिफरेंस है, लेकिन जब हम तीनों ग्रुप को देख रहे हैं अलग अलग तो पहले हम उनकी पहली वैल्यूज को लेना। सिर्फ अभी हम 0 वाले ग्रुप यानी नॉन स्मोकर्स को कंपेयर कर रहे हैं, दूसरे केस में हम स्मोकर्स को कंपेयर कर रहे हैं, और तीसरे के पास्ट स्मोकर्स को, और तीसरे केस में हम करंट स्मोकर्स को कर रहे हैं। वो रिजल्ट आपको यहाँ भी शो करेगा, लेकिन वो उससे बेटर है कि आप इस तरीके से लिखें कि पहला ग्रुप दोनों से डिफरेंट नहीं है, सॉरी पहले ग्रुप का डिफरेंस नहीं है, दूसरे ग्रुप का डिफरेंस नहीं है, हाँ ग्रुप 2 का जो कि करंट स्मोकर्स हैं उनका डिफरेंस आ रहा है नॉन स्मोकर से। यानी स्प्रिंट टाइम।
सर ये तो फर्स्ट केस में भी आ रहा है कि जो 0 का 2 से।
मैडम एग्जैक्टली आ रहा है, वो पूरा आ रहा है, लेकिन क्या है कि हम 1 बाय 1 अगर ग्रुप के साथ चलें तो इस टेबल का इंटरप्रिटेशन बेटर वे में होगा। यहीं पर अगर हम लिख देंगे तो कोई मतलब नहीं रह जाता है। बात वही है, आप यहाँ पर देखिए ना, 0 और 2 में भी वही चीज आएगी, 2 और 0 में भी वही आएगी। तीनों को 3 लेवल पर वो जो है चेक कर रहा है। ठीक है, यू आर वेरी राइट कि हाँ वहीं पर हम लिख सकते हैं, वहीं पर दिख रहा है, लेकिन अगर हम ग्रुप वाइज चलें तो बेटर रहेगा ना कि पहले पहले हम नॉन स्मोकर्स को देखें, फिर उसके बाद स्मोकर्स को देखें, उसके बाद पास्ट स्मोकर्स को देखें। आप चाहे तो उसी के बेस पर लिख सकती हैं, पहले ही के बेस पर लिख सकती हैं, पहले और दूसरे के बेस पे ही आप पूरी चीज लिख सकती हैं। पहले के केस में आप देख लीजिए कि नॉन स्मोकर्स और पास्ट स्मोकर्स के बीच कोई डिफरेंस नहीं है, लेकिन स्मोकर्स और नॉन स्मोकर्स के बीच डिफरेंस है। सिमिलरली अगर सेकंड केस देखें तो अगेन स्मोकर्स और नॉन स्मोकर्स, पास्ट स्मोकर्स और नॉन स्मोकर्स के बीच कोई डिफरेंस नहीं है, लेकिन जो है और साथ ही साथ करंट स्मोकर्स और पास्ट स्मोकर्स के बीच भी कोई डिफरेंस नहीं है। लेकिन थर्ड केस में क्या है, करंट स्मोकर्स और नॉन स्मोकर्स के बीच डिफरेंस है, और स्मोकर्स, करंट स्मोकर्स और पास्ट स्मोकर्स के बीच कोई डिफरेंस नहीं है। मतलब टेबल 1 और 2 में जो दिख रहा है वही आपको टेबल 3 में भी, थर्ड कैटेगरी में भी दिखेगा। It is a kind of 3 by 3 matrix it is making actually. So you can write on the basis of first only, okay, that is from the above table it is clear that there exists no significant difference between the past smokers and non-smokers. However, there exists a significant difference between current smokers and non-smokers. Moving ahead, you can say that also there exists no difference between the past smokers and current smokers. ठीक है?
ओके सर।
Any confusion in this? So इसीलिए मैं एक स्टेप पर सिर्फ एक ग्रुप को ही कंपेयर कर रहा हूं ताकि कोई कंफ्यूजन ना रहे। पहले उसमें सिर्फ हम करंट स्मोकर्स सॉरी पास्ट स्मोकर्स और नॉन स्मोकर्स को कंपेयर कर रहे हैं, दूसरे में हम जो है करंट स्मोकर्स और इसको पास्ट स्मोकर्स का अगेन दे रहा है डेटा, और थर्ड में बता रहा है आपको कि हाँ करंट स्मोकर्स और पास्ट स्मोकर्स के बीच सिग्निफिकेंट डिफरेंस नहीं है, जो भी सिग्निफिकेंट डिफरेंस है वो आ रहा है नॉन स्मोकर्स और करंट स्मोकर्स के बीच। सो फाइनली वी कैन कंक्लूड that there exists no significant difference, because here it is telling that at least one of the group differs. This ANOVA table says that at least one of the group differs. So further, which of the group is differing, because this will ANOVA will tell you only that at least one of the group differs, but at which of the group differs, that you will know through multiple comparisons or post hoc analysis. So post hoc analysis is telling you that there exists no significant difference between the sprint time taken by past smokers and non-smokers. Also, there exists no significant difference between sprint time taken by current smokers and past smokers. However, there exists a significant difference between sprint time taken by non-smokers and current smokers.
सर एक बार अनोवा टेबल में थोड़ा सा आप बताएंगे बिटवीन ग्रुप्स एंड विद इन ग्रुप्स।
क्या चीज?
सर व्हाट इज द मीनिंग ऑफ दिस बिटवीन ग्रुप्स एंड विद इन ग्रुप्स जो सर अनोवा टेबल में?
ओके, इसका मतलब क्या है? व्हाट यू वांट टू नो, मतलब इसका मतलब क्या है या क्या चीज? See, actually, when you do ANOVA, so you have already 3 groups. So first it will compare the sprint time between the groups, means between group 0, 1 and 2, and calculate the sum of squares. And then it will calculate sprint time within the groups, मीन्स ग्रुप 0 के अंदर जितने रिस्पोंडेंट हैं उनके बीच तो कहीं डिफरेंस तो नहीं है, ग्रुप 1 के बीच जितने रिस्पोंडेंट्स हैं उनके बीच तो डिफरेंस नहीं है, ग्रुप 2 के बीच जितने रिस्पोंडेंट्स हैं उनके बीच तो डिफरेंस नहीं है। उसके बेसिस पर आपको ये देगा उनके सम ऑफ स्क्वायर्स बिटवीन द ग्रुप्स एंड विद इन द ग्रुप्स। फिर मीन स्क्वायर एरर देगा आपको, सॉरी मीन स्क्वायर एरर देगा आपको between the groups and within the groups. So what happens जब हम ANOVA टेस्ट करते हैं तो वो 2 चीजें चेक करता है, डिफरेंस बिटवीन द ग्रुप्स। हमारे पास 3 ग्रुप्स थे, पास्ट स्मोकर, नॉन स्मोकर्स और करंट स्मोकर्स। तो एक बार वो चेक करेगा क्या डिफरेंस नॉन स्मोकर्स, पास्ट स्मोकर्स और करंट स्मोकर्स के बीच डिफरेंस है कि नहीं है। उसके बाद फर्दर चेक करेगा कि जो पास्ट स्मोकर्स वाला ग्रुप था उनमें जो रिस्पोंडेंट है कहीं उनमें तो डिफरेंस नहीं आ रहा है। उसके बाद जो नॉन स्मोकर्स हैं उनमें, मतलब हर इंडिविजुअल ग्रुप के भी पहले वो सारे ग्रुप्स के बीच डिफरेंस कंपेयर करेगा, और फिर उसके बाद हर ग्रुप के रिस्पोंडेंट्स के बीच भी डिफरेंस कंपेयर करेगा। क्लियर है मैम, या अभी इट
या
नीड्स?
यस सर, आई गॉट इट सर, थैंक यू सर। सर एक और मेरा क्वेरी था कि लाइक इन थ्योरी हम ये पढ़ते हैं कि जो टी टेस्ट होता है दैट इज यूज्ड फॉर स्मॉल सैंपल साइज, तो कैन वी यूज इट फॉर लार्ज सैंपल साइज ऑल्सो? जैसे
अच्छा,
आपका जो सैंपल था 435 का था, इट वाज अ लार्ज सैंपल साइज।
समझ गया मैं, समझ। वो आपने पढ़ा होगा कि 30 से अगर अबव है तो हम टी टेस्ट नहीं लगाते हैं।
हाँ यस सर।
मैम वो सिर्फ वन सैंपल टी टेस्ट में का कॉन्सेप्ट है। जब हम चेक करना चाहते हैं कि हमारा सैंपल, क्योंकि वन सैंपल टी टेस्ट में हम यही कंपेयर करते हैं ना, पॉपुलेशन मीन और सैंपल मीन में डिफरेंस है कि नहीं है। तो वो बहुत ओल्ड स्कूल ऑफ थॉट है कि जब हम इंडिपेंडेंट और पेयर टी टेस्ट में ऐसा कुछ भी नहीं है। ये सिर्फ वन सैंपल टी टेस्ट के लिए था, बट दैट इज द ओल्ड स्कूल ऑफ थॉट। अब उसका कोई मतलब नहीं है, पहले ये हुआ करता था, अभी उसका कोई मतलब नहीं है।
ओके सर।
सर आई हैव वन क्वेरी ऑल्सो कि कल जैसे आपने अपने स्टेटमेंट में लिखा था पॉपुलेशन मीन एंड सैंपल मीन, बट सर हाउ इन प्रैक्टिकली हाउ कैन वी कैलकुलेट पॉपुलेशन मीन? आई थिंक इट्स वेरी डिफिकल्ट टू ऑल ऑफ द रिस्पॉन्डेंट।
मैम वी विल नॉट कैलकुलेट द पॉपुलेशन मीन। पॉपुलेशन मीन तो ऑलरेडी स्टेब्लिश्ड है, हाइपोथेसाइज्ड होता है मैम, वो हाइपोथेसाइज्ड मीन है।
सर हम जैसे कि मैं अपना जो रिसर्च वर्क है ब्लॉकचेन पे कर रही हूँ, तो
हम्म।
मतलब पॉपुलेशन मीन सर कैसे कैलकुलेट हम करेंगे अपने?
मतलब आपका टॉपिक में क्या ऐसा कुछ है, कुछ जिसमें आपको पॉपुलेशन मीन कैलकुलेट करने की जरूरत हो?
सर एज तो अभी तो फर्स्ट सेमेस्टर स्टार्ट हुआ है, तो
तो जब वो सिचुएशन आएगी तब आप मेरे से कांटेक्ट करिएगा, मैं बताऊंगा कि उसमें पॉपुलेशन मीन जैसे ऐसे समझिए। मेरी क्लास में 50 स्टूडेंट हैं, ओके। अच्छा आप एक बताइए, बात बताइए, एमबीए में अगर स्टूडेंट है तो उनकी एज कितनी होगी?
सर अप्रोक्सी 20 to 23।
एक एक वैल्यू बताइए।
सर 20।
एवरेज, एवरेज कितना होगा?
20 या 21।
21। ये ये एज कहाँ से आई आपके पास?
सर एज कैलकुलेटेड वैल्यू है कि इतने इयर्स में इसने अपना ग्रेजुएशन कंप्लीट किया होगा, देन आफ्टर ही इज परसुइंग एमबीए।
आपने हुआ किया होगा, देखिए फिर आप अपने स्टेटमेंट में जाइए। आप एक हाइपोथेसाइज्ड मीन ले रहे हो। आप यही तो मान रहे हो कि अगर कोई बच्चा ग्रेजुएशन में होगा तो उसकी एज 21 के आसपास होगी, यही तो कह रहे हो आप।
यस सर, यस सर।
ये हाइपोथेसाइज्ड मीन है मैडम, यही तो पॉपुलेशन मीन है। अब आप अपनी क्लास में, आपकी क्लास में जो 50 बच्चे हैं एमबीए के, आप उनकी एज का एवरेज लेकर के कैलकुलेट करेंगे कि वो क्या 21 से ज्यादा है या कम है। ये आपका सैंपल मीन हो गया।
ओके सर, ओके।
पॉपुलेशन मीन कैलकुलेटेड नहीं होती, वो एक हाइपोथेसाइज्ड मीन होती है। जैसे कल के केस में हमने देखा कि सीडीसी ने बताया है कि 20 साल के अबव लोगों का अगर उसने पॉपुलेशन में कोई सर्वे किया होगा या ऐसे एक एग्जम्पशन बनाया कि उनकी एक एवरेज वैल्यू 66.5 इंचेस होती है। अब आपके पास जो डाटा है उसमें आप देखोगे कि हमारे पास जो लोग हैं उनकी हाइट क्या 66.5 इंच से ज्यादा है या कम है। जैसे अभी मैंने आपसे क्वेश्चन किया कि आप बताओगे कि एमबीए स्टूडेंट, एमबीए में पढ़ने वाले स्टूडेंट की एवरेज एज क्या होनी चाहिए या क्या होगी, तो आपने एक आउट ऑफ योर एक्सपीरियंस या जैसे भी एक अजम्पशन बना के कह दिया ये 21 होनी चाहिए। अब आपकी क्लास में दिस इज एक्चुअली द पॉपुलेशन मीन और हाइपोथेसाइज्ड मीन। अब आपकी क्लास में जो 50 स्टूडेंट्स हैं आप उनकी एज लेंगी, उसका मीन लेंगी, दिस इज द कैलकुलेटेड मीन। अब आप देखेंगे कि आपकी कैलकुलेटेड मीन हाइपोथेसाइज्ड मीन से ज्यादा है या कम है। दैट्स हाउ यू से दैट सैंपल मीन इज मोर देन द population mean or less than the population mean.
ओके सर, ओके।
I hope I answered your question.
यस सर।
Okay, clear?
यस सर।
Okay. So now that what is the meaning of this between groups? Within groups, it's very simple. When we do the ANOVA analysis, it tests the difference between the groups, and then further it tests the difference between members of the groups. मीन्स जीरो के अंदर जितने हैं क्या उनमें डिफरेंस आ रहा है या नहीं आ रहा है, ऐसे वेरिएशंस को चेक करता है। एक्चुअली इसका एक स्टैटिस्टिकल सिग्निफिकेंस ये सारी वैल्यूज इसलिए आती हैं क्योंकि फाइनली जो हम एफ या अनोवा की वैल्यू निकालते हैं वो रेशियो होता है रिग्रेशन मीन स्क्वायर एमएसआर और एमएससी का। उसको कैलकुलेट मतलब मैनुअली कैलकुलेट करने का एक लंबा तरीका है, वो मैं बताऊंगा तो 1 घंटे भी यहीं चले जाएंगे, उसका कोई मतलब भी नहीं। यहाँ पर मैथमेटिकली वो डेरिवेशन है, तो वो सारी चीजें यहाँ से आती हैं। ओके, सो दिस इज सम ऑफ स्क्वायर्स, रिग्रेशन सम ऑफ स्क्वायर्स, फिर टोटल सम ऑफ स्क्वायर्स आप लेते हैं, ठीक है, उसको फिर डिवाइड करते हैं मीन सम मीन उससे मीन स्क्वायर एरर से, मीन स्क्वायर एरर वगैरह इन सब से, मतलब वो एक लंबा तरीका है। तो आपको फाइनली 9.21 मिलेगा।
Yes, sir.
Okay, now moving ahead. So this is the ANOVA will tell you only that at least one of the group differs. Multiple comparison will tell you that actually which of the group differs. Now moving on to the test of association. We have two tests of association, and these two tests of associations are chi-square test and correlation. So let's see. Okay. Is this visible to you?
Yes, sir.
Okay. So this chi-square test of independence, there are two kind of tests in chi-square. One is chi-square goodness of fit, and another one is chi-square test of independence. Chi-square goodness of fit is used when we want to do a model fit, whereas you have some non-parametric variables. Whereas chi-square test of independence is the test which is used to test the relationships, or simply we call it as chi-square. So this test determines whether there is an association between the categorical variable. Now here this is not the case of continuous variables. So in both the dependent cases and independent cases, you have a categorical variable, that is the variable taken on categorical scale, that is the either the ordinal scale or the nominal scale. Okay, so this tests the relationship between categorical variables, and it is basically chi-square test is basically a non-parametric test. However, this test is often used interchangeably because it is said that chi-square is the single test which comes into the category of parametric also and non-parametric also, but basically it is a non-parametric test. So this test is commonly used to test the following: statistical independence or association between two or more categorical variables. So suppose if you have two or more categorical variables and want to test the association between them, then you will go for chi-square test of association. Let's say you have two groups, two categorical variable, smoker and non-smoker, and another two groups, that is the dependent group, cancer and non-cancer. Now you want to test whether smoking causes cancer or not. So now you have two groups, smoker and non-smoker, and the two groups, cancerous and non-cancerous. Now you see both of your groups are categorical in nature. Means they are divided into categories, either smoker or non-smoker, or another group is cancerous or non-cancerous. If you have a situation like this, then you will go for chi-square test of association. So it will give you a 2 by 2 matrix. That is, on one side you will have smoker and non-smoker, other side you will have cancerous and non-cancerous. You will be presented with four situations: smoker, cancerous, smoker, non-cancerous, non-smoker, cancerous, smoker, I'm sorry, non-smoker, cancerous, non-smoker, non-cancerous. So for doing the chi-square test of association, your data must uh, uh, fulfill the following requirements. You should have two categorical variables, and then in the categorical variables, you should have two or more categories for each variable. Okay, like I said, there is two categorical variable, that is smoker and cancerous. Among this, you have two categories. One category is smoker, and the one is non-smoker. You have groups. Under in the other variable, you have cancerous and non-cancerous. There should be independence of observations. That is, there should be no relationship between the subjects in each group, and the categorical variable are not paired in any way. That is, the pre-test and post-test situations should not be there. If there is the pre-test and post-test situation, then you should not use chi-square test of independence. Rather, you should move on to another test which is known as McNemar's test. You should have relatively large sample size because expected frequencies for each cell should be at least one. And expected frequencies should be at least 5 for the majority of the 80% of the majority of the cells. So you should have relatively large sample size, means your category should at least have frequency of 1. ओके, ऐसा नहीं हो कि कोई एक कैटेगरी का कोई रिप्रेजेंटेशन ही नहीं है. एटलीस्ट मिनिमम वन रिप्रेजेंटेशन होना चाहिए हर कैटेगरी का. Expected frequencies for each cell should be at least 1, and expected frequencies should be at least 5 for majority of the cells. So minimum it has to be 1, and moderately, optimally it should be at least 5 for majority of the cells. So let me explain this to you. Let's say you have this 2 by 2 table. On this side you have smoker, on this side non-smoker, in two categories. On sorry, on this side, let's say you have cancerous, and this side non-cancerous. So each of the cells should have at least filled with at least one number, one frequency minimum, and most of the groups should have at least 80% or 5 frequencies. So this is the requirement, data requirement for chi-square test. So you should have such relatively large sample size. Now the hypothesis in case of chi-square is that the null hypothesis could be that variable 1 is independent of variable 2, or variable 1 is not independent of variable 2. Or you can write like this, that variable is not 1 is not associated with variable 2, and alternate variable 1 is associated with variable 2. Since it is a test of association, so you will not write a significant difference exists or not. Here you will write whether there is a significant association between both the variables or not. So first null hypothesis will say that there is no association between variable 1 and 2, and alternate hypothesis will say that there is association between variable 1 and 2. Or you can write it that variable 1 is independent of variable 2, means not associated, or variable 1 alternate you can write as variable 1 is not independent of variable 2, that is means there exists some association. I won't go into mathematical statistics. There are a lot of mathematical statistics that can be done. I hope I have somewhere the formula written for it. I'll show it to you later. So here the problem statement in our case that the same data set. So in the sample data set, you can see here this is our sample data set. If you see here, there is a category of smokers, and in this data set, if you see, the respondents were asked about their gender and whether or not they were cigarette smokers. So gender was divided into male and female, and their smoking status was divided as non-smoker, past smoker, and current smoker, as we have taken in the previous case. Now see, both are categorical in nature, gender and smoking, and we want to test that whether there is any association between the smoking behavior and gender. Since we have two category, we have both the variables as variable 1 and 2, both are categorical variable. There is nothing called dependent or independent in that case. We have simply two variables which are categorical in nature. If they are categorical variables and we want to see that whether gender has some relationship with the smoking behavior or not, means we test the hypothesis, want to test the hypothesis in our case that gender is independent of smoking behavior or gender is independent of smoking behavior. Or in other words, null hypothesis, we are framing that gender is associated with smoking behavior, and the alternate we are saying that gender is associated with smoking behavior. Am I clear till here?
Yes, sir.
Okay. Now go for chi-square test. Since this is the situation, we have categorical variable, we have to test the association, so we will go for chi-square test. So analyze, you will see here chi-square, where it is. Yes, cross tabs. Since chi-square statistic is based on the cross tabulation, so go for the cross tabs. So what we will put over here? In the rows, what we want to put? You can put any. What you want to put in rows?
So gender.
Okay. What you want to put in column? Smoking. In statistics, chi-square is by default selected. Continue. Format, it's okay. By default. Cells, okay. Continue. Click on OK. Now you have got here. Now what does this table tells you? First table will tell you that non-smoker, male, females were, sorry, yes, 0 as females, 149, 13, 31, total 193. And in smokers, you have again 209. Okay, one thing of this chi-square test is that the total number of rows and total number of columns are equal. So if you just add 193 and 209, you will get 402. Either you go through column wise, here also you will get the same value, and here also you will get the same values. So total number of rows is equal to total number of columns. They are the thumb rule in chi-square test. Now, just go for this. What is the value of the test statistic in this case? Pearson chi-square value is 3.17.
Yes, sir.
Okay. What will be the degree of freedom in this case?
2.
From where this 2 is coming? Because chi-squares, in chi-square you have to do some mathematical calculation also. See, in chi-square degree of freedom is equal to row minus 1 into column minus 1. So how many rows we had? We
सर
had 3.
रो हमने जेंडर लिया था सर, तो
So 2 rows and 3 column.
2 rows and 3 columns. So it will be 2 minus 1 into 3 minus 1. Finally कितना हुआ? 2 मिला. So ये हमें लिखना पड़ेगा. Because this total value of the chi-square is actually, if we write it mathematically, it will come out to be observed frequency minus expected frequency. Okay.
Divided by expected frequency.
उसका square and divided by expected frequency, expected cell count. और expected frequency निकलेगी वो row total into column total by grand total. So ये पूरा फॉर्मूला होता है. So finally अगर हम इस तरीके से निकाल रहे हैं टेबल से, तो हम ये लिखेंगे कि हमारी डिग्री ऑफ फ्रीडम 2 इस वजह से आई. जैसे हम टी टेस्ट में लिखते हैं कि n-1 है, यहाँ पर हम कहते हैं रो -1 इंटू कॉलम -1. तो हमारे केस में ये 2 आएगी. So now if I want to write its interpretation, so what I can write? See, chi-square at the degree of freedom 2 is equal to 3.17.
17.
At this p value is 0.205, isn't it? At degree of freedom 2 and chi-square value of 3.17, what is the value of p? 0.205. Look at the chi-square table.
yes sir.
So if it is coming to be 0.205, it means that null hypothesis is accepted. It's not rejected. And null hypothesis is accepted means variable 1 is independent of variable 2, means variable 1 is not associated with variable 2, or you can write there is no association between gender and smoking behavior. Means smoking behavior is equal across all genders. Genders do not differ in terms of their smoking behavior. Am I clear?
Yes, sir.
There is no association. जेंडर का कोई लेना देना
Yes.
स्मोकिंग बिहेवियर से नहीं है। अदरवाइज यही अगर केस होता कि पी इज लेस देन अल्फा तो हम कहते कि नहीं, जेंडर का लेना देना है। और फिर हम ये इसको देख करके, इस टेबल को देख करके बता पाते कि कितना लेना देना है, कितना परसेंट, कितना आ रहा है। ठीक है, चलिए। नाउ सेकंड, okay, this chi-square test of association is used only, remember, when both of your variables are categorical in nature. It cannot be the case that one variable is categorical and another one is continuous or metric. अगर ऐसा केस होगा तो आप chi-square टेस्ट नहीं लगाएंगे। उसके लिए फिर आप नॉन पैरामेट्रिक टेस्ट लाइक मैक्निमस एंड अदर थिंग्स यू विल अप्लाई। ये तभी हो सकता है जब दोनों के दोनों, बोथ ऑफ योर वेरिएबल्स, दे आर कैटेगोरिकल इन नेचर। नाउ मूविंग अहेड, so already we have discussed. Now correlations. So this correlation is again of two types. One is bivariate correlation, जो normally हम करते हैं, Pearson product moment correlation, and partial correlations. Now this Pearson correlation is also known as Pearson product moment correlation and Spearman correlation. Pearson correlation is used when your data is metric in nature, or when you are doing the parametric test, also known as Pearson product moment correlation. The non-parametric equivalent means when your data is not normally distributed and you have to check for the correlation. Then rather than going for Pearson correlation, you will go for Spearman correlation, or also known as interclass correlation, ICC. Then there is a Kendall-Tau correlation, which is again a non-parametric correlation.
Sir, please repeat once again when we use Pearson and Spearman.
See, when your data follows the normal distribution, then you go for Pearson correlation. Okay? Is my voice clear?
Yes, sir.
And if your data is skewed, not normally distributed, and you want to test the association, then you will go for Spearman correlation. Clear?
Yes, sir. Yes, sir.
Okay. Pearson correlation is also known as Pearson product moment correlation, and Spearman correlation is known as interclass correlation. So it's only about whether the data is normally distributed or not. So parametric correlation is known as Pearson correlation, non-parametric correlation is known as Spearman correlation. Simply. Kendall-Tau is another bivariate correlation which is non-parametric in nature, and then we have biserial and point biserial correlations. Suppose if you have two variables and also there is a third variable which is affecting the relationship between these two variables, then you want to control that variable and check the correlation, then this will be called partial correlation. However, we'll focus only today for the Pearson product moment correlation. Let me give you an example. Suppose you want to know that increasing heat, how much effect it, how it will affect the boiling time of water. अगर हम हीट बढ़ाएंगे तो वाटर का बॉइलिंग टाइम घटेगा बढ़ेगा?
कम होगा।
कम होगा। तो इसे हम क्या कहते हैं? निगेटिव कोरिलेशन। यानी एक वेरिएबल को बढ़ाने पे दूसरा वेरिएबल अगर घटता है तो हम इसे कहते हैं निगेटिव कोरिलेशन। कोरिलेशन ऑलवेज रेंजेस फ्रॉम -1 to +1, यानी -100% से +100%। नंबर 1। तो एक एग्जाम्पल हम लेते हैं कि अगर हम हीट बढ़ाएं, बर्नर का नॉब ऑन करें या बर्नर के नॉब को बढ़ाएं, तो हीट क्या होगा, बॉइलिंग टाइम क्या होगा, वो कम हो जाएगा। इफेक्ट तो हो रहा है, ये रिलेशनशिप है दोनों में, बट ये निगेटिव रिलेशनशिप है। रिलेशनशिप है, सिग्निफिकेंट है, निगेटिव है। एक चीज को बढ़ाने से दूसरी घट रही है। अगर एक वेरिएबल को बढ़ाने से दूसरा वेरिएबल बढ़ता है तो इस केस को हम कहते हैं
पॉजिटिव।
पॉजिटिव। नाउ कमिंग टू दिस सिचुएशन, क्या वाटर का बॉइलिंग टाइम सिर्फ आपके हीट पर डिपेंड कर रहा है?
No, sir. It is depends on the size of the vessels also.
It depends on the size of the vessel. It also depends on कि previously उस वाटर का टेम्परेचर कितना था, रूम टेम्परेचर कितना था। रूम टेम्परेचर पर भी तो डिपेंड करेगा ना।
Yes, sir.
So again, this is the third variable, but you don't want to consider this variable. You want to control this variable, keeping other things constant. If you want to keep other thing constant and then trying to find the correlation, then this is known as partial correlation. Type of vessel, size of vessel, room temperature, keeping all these things as control variable, then this correlation is known as partial correlation. When you are not controlling, then simply it remains a bivariate correlation. Like I'm saying, if I give more lectures to the students, they will have more knowledge. Such kind of correlation is bivariate correlation. Now, is more lecture directly related to the knowledge of the students? Of course not. There is some role of their IQ also. But I want to keep this IQ as constant. I want to keep this IQ as controlled variable. Then this kind of correlation will become partial correlation. Getting my point? Any confusion in this?
No, sir.
Okay. So as of now, I am just focusing on the bivariate correlation or Pearson product moment correlation, not this Spearman one or any other. So this produces a sample correlation coefficient R, which measures the strength and direction of linear relationships. So it will measure the strength, how much degree of correlation is there, and whether it is positive or negative. So if you have, let's say, minus 72.5 R value, so it doesn't mean that there exists a weak correlation. Still, it's a strong correlation, 72.5% correlation, but it is negative in nature. Means if you increase X by 100%, Y will decrease by 72.5%. Means there exists a strong correlation. Here, negative or positive value does not tell you the strength of the correlation. It tells you only the direction of the correlation. Only numbers tells you the strength of the correlation. Okay. And correlation evaluates whether there is statistical evidence for a relationship among the same pairs of variables in the population. And this is represented by a population correlation coefficient known as rho. This is a parametric measure. Already I have told you the non-parametric equivalent is Spearman. So this is also known as Pearson correlation or Pearson product moment correlation. The common uses of this correlation is that it checks the correlation among pair of variables and correlation within and between set of variables. And this correlation indicates whether there is a statistically significant linear relationship. We are not talking of quadratic relationship. Here, both the variables should be linearly associated with each other. Okay, there should means so it checks that whether there is a significantly linear relationship between two continuous variables or not. Here you will take continuous variable because it is a parametric test. Then it checks the strength of the linear relationship. Okay, so how close the relationship is to being a perfectly straight line. Perfectly straight line is called 100%. and the direction of the linear relationship, positive or negative, means increasing or decreasing. Data requirements are that you should have two or more continuous variables, means taken on interval or ratio scale. Cases should have values in both the variables. Linear relationship should be there in between the variables. Cases should be independent of each other, they should not affect each other. There should be bivariate normality. Data should be taken from random sample, and there shouldn't be any outliers. This is the decision tree for correlations. If you have a metric data, it is normally distributed and the sample size is small. However, now this doesn't stand true. You can do on large sample sizes also. So sorry. Yes, you can do on large sample sizes also. Say if your sample size is large, you can will go for Pearson correlation. If your sample size is small, you will go for Spearman correlation. If your data is categorical, then also you will go for Spearman correlation. If your data does not follow the normal distribution, then also you can go for Spearman correlation. So for conducting Pearson correlation, your data should be metric, that is taken on a continuous scale, ordinal or nominal, interval or ratio. It should follow the normal distribution and sample size should be large enough. The hypotheses are that we can have two-tailed hypothesis and one-tailed hypothesis. So two-tailed hypothesis says that the population correlation coefficient is zero, that is there is no association, and alternate says that the population correlation coefficient is not zero, that is there exists a correlation between the two variables. In one-tailed significance test, you can say that population correlation coefficient is zero, again the same thing, or in other case you won't say that population correlation coefficient is not equal to zero, you will say that it's greater than zero, because it's unidirectional, one till significant. Either it will be equal to zero, or it will be greater than zero, or it will be smaller than zero. Okay, the population correlation coefficient is less than zero, a negative correlation could exist. If it is greater than zero, positive correlation could exist. If it is less than zero, negative correlation could exist, where the rho, that is that it's not P, it's the rho, is the population correlation coefficient. Now your data should include two or more continuous numeric variables, is defined as a scale, which will be used in the analysis, and each row in the data set should represent one unique subject, person, or unit. Now coming to the problem statement. Now in the data set, we are taking two variables, height and weight, and we want to check that how height and weight are correlated with each other. So you can see here we have the height and weight, and we want to see that whether there exists some correlation between the height and weight or not. So before that, we can go for analyze descriptives and descriptives, and we will take height and weight. Here you can see that height ranges from minimum 55 to 84.4, whereas weight is taken in, I think it's not in, it's in pounds. So height ranges from 55 to 84.4 inches, whereas weight ranges from 101 pounds to 350 pounds. Okay. Now we also want to see that there is a linear relationship between them or not, because the very first thing for correlation is checking for linear relationships. So here you can go to graphs and scatter plot. I hope it will make a simple scatter. So on the y-axis, I am keeping weight. On the x-axis, I am keeping height. You can keep any. Okay. Now, if you draw a line from here, okay, you will see that all these are across this line. Okay, and as the value of x increases, similarly the value of y also increases. You can see. Are you getting this?
Yes, sir.
अगर इसके बीच में हम एक लाइन बना दें तो आप देखेंगे जैसे जैसे x की वैल्यू बढ़ रही है वैसे वैसे y की भी वैल्यू बढ़ रही है. आप इधर से देखते जाइए. So there exists a linear association. So okay, here in this we don't have the option of putting a this line actually. Otherwise I could have put a line. There is no option here. तो आपको ज़्यादा क्लियर हो जाता. But yes, by seeing the graph you can see that there is a linear association. Means as x increases, y also increases. Okay. Now you can go for the bivariate correlation in this case. Analyze. Go for bivariate correlation and take the two, height and weight. Now it's up to you whether you want to keep it one-tailed or two-tailed. If one-tailed, then that will be the hypothesis that I have told you. This will be your hypothesis. That P is equal to, means null will be P is equal to 0, that is no correlation exists, and H naught will be P is greater than 0 or P is less than 0. If you are taking two-tailed, then you will frame hypothesis like this, that P is equal to 0 and P is not equal to, sorry, rho is equal to 0 and rho is not equal to 0. Okay, it depends on you whether you want to go for one-tailed t-test or two-tailed test. In both the cases, your hypothesis will, the way you define your hypothesis will differ. Though results won't differ, but hypothesis will differ. As of now, I am taking it two-tailed. By default in SPSS, if you will do it, will by default take two-tailed. Now see this correlation table. What it is indicating. See, correlation of height itself with itself is 1, क्योंकि height का height से तो 100% आएगा. But correlation of height with weight is how much?
It's 0.513.
0.513. And number of observations are 354 in case of weight. Okay, based on 354 observations. Correlation in, if you see this second table, correlation of weight with itself is 100%, weight to weight, and correlation of weight with height is again 0.513 based on, okay, correlation of weight with weight is 100% based on 376 observations, and with the weight and height it's 0.513 based on 354 observations. So what you can infer with this? So how we will write? In this case, we'll write, sorry, R is equal to, this small r is equal to Pearson correlation, 0.513, P is less than 0.05, null, hypothesis rejected. This means there is a correlation between the two variables, height and weight, and it stands. There might be correlation, but if it does not stand statistically significant, it's of no use. And it stands statistically significant at 95% confidence interval or 5% confidence, or sorry, 5% for this, what we call it, sorry,
So level of significance.
yeah, significance level. Sometimes it misses out of my significance level. Now we have said that there is a correlation between height and weight. It is statistically significant also, but how much correlation is there? So correlation is equal to 0.513 or 51.3%, which is a moderate correlation. So this shows, and also this is a positive correlation. So this shows, because this is 0.513 is not negative in nature. So correlation is positive, which means if height is increased by 100%, it increases by 51.3%. तो क्या हम इसको ऐसा भी लिख सकते हैं कि weight is increased by 51.3%, height will increase by 100%? No, because you have to check it unidirectionally, the relationship between height and weight. On the x-axis, that's why we have taken height. So if height, we want to check how height is correlated with weight. So if height is increased by 100%, weight will increase by 51.3%. And the strength of correlation is moderate. Am I clear on this?
Yes, sir.
Okay. So for today we are done. And if you have any questions, I'll be happy to answer.